Hi all, this is Team 9. My name is Vimash and our language is GKV. Coming to the features, we have arithmetic operators and data types of integer, boolean and stack. We are supporting parameterized functions, local and global variables, assignment operations, decision making if statement, iterative while statement and recursion. Coming to the tools used, we have used ANTLR 4 for writing grammar, generating parser, and translation to the intermediate code using listener class, although the runtime environment has been developed using Java. On your screen, we can see a sample program of simple addition. The first code is the high level code, the second one is the intermediate code generated, and the last one is the final output generated by the runtime environment. These are some of the keywords which we are using in our high level language. For assignment, we use the same orthodox assignment sign. For print, we use the show keyword. For calling a function, we use call keyword followed by function name, then the with keyword followed by parameters. For function definition, we use the keyword function followed by function name, then keyword uses followed by parameters, and lastly the keyword returns followed by the return data type. For decision making, we use the keyword if and then the condition followed by the keyword then and the sequence of statements. And also we use the keyword else and the sequence of statements. For loop implementation, we use the keyword while followed by condition. Also, we are using relational operators like and or, stack operators push and pop, and comparison operators equal to, less than, greater than, less than or equal to, greater than or equal to, and last but not the least, not equal to. The semicolon determines the end of each statement in our high level language. Next section, intermediate code, will be explained by my peer Gautam.
Hi, I'm Gautam and I will explain about intermediate code generation. I will take function as an example to demonstrate this. This is the grammar for function definition in our language. This is the high level language for function definition in GKV. It takes two integers as parameters and returns the computed sum as result. This is the corresponding parse tree for function definition. Once we have the parse tree, we can use listeners to convert high level language to intermediate code. A listener is a class in Java which triggers a method when a particular parse rule is matched. This is an example for intermediate code for function definition. A program in our language is a series of statements or functions. A statement can be a simple statement or a compound statement. A simple statement can be an assignment statement, a declaration statement, a function call, a display statement, a stack push or a stack pop, or a return statement. A compound statement can be an if-else statement or a loop statement. You can also see the grammar for function definition. GKV compiler is the entry point for lexing, parsing, and intermediate code generation. It takes high-level language file as input and converts it to ANTLR stream. This is fed to Lexer, which tokenizes the stream. This token stream is fed to the parser, which checks for semantic correctness. Once lexing and parsing is done, we begin intermediate code generation using GKV Walker. GKV Walker extends GKV based listener, which gives a handle to execute a method when a grammar rule is matched. On the screen, you can see a handler for function definition. I will show you a small demo for intermediate code generation. Now my peer Kalul will explain about runtime.
Hi, I'm Kalol and now I'm going to demonstrate the runtime of our language. This runtime is developed in Java. This takes the intermediate language, that is IGKV file, as input and produces output in the console. So let me brief you how does it works. It parses the intermediate language line by line and search for the keywords, and based on these keywords it will perform the action. For memory management, we have used map and stack. Stack is mainly used to perform immediate actions like storing data, copying it, and perform action and again pushing it. Whereas map is used to maintain the symbol table. We have also maintained the local and global scope by defining map and stack. Now let me run one intermediate file and explain how it works. Let's make a multiplication table of 2 with our language and demonstrate it with the intermediate file. So let's look at the high level code once. This is our high level code, and as per our team member already discussed and as per the predefined grammar, this has been written. We use the while loop for the looping constraint. And now let's look at the corresponding intermediate file. This intermediate file has its own format like declaring, pushing the value, set the value. The most important part of this loop is this loop head. Loop head is the point where it started. And once a loop is started, it will check for some condition. The condition is checking with this condition. This is the less than equal to condition. So here in this case, whenever the I is less than 10, the loop will iterate and it will search for a jump clause to go to back to the loop head and make a proper loop. So now I will run it and show how it converts in the runtime. So this is the runtime Java file, which takes the intermediate file or IJKV file as input and performs line by line parsing to search for keywords. As I have already mentioned about the local and global symbol table, let's check that. In main, we have defined the stack and map as global symbol table in loop, and in the loop scope, we have defined the local symbol table. So let's run this runtime and get the desired result. Here in this argument, we need to provide the file name, and when we run, we can see the desired output is there. So this is how we demonstrated our full language flow from the high level language to the intermediate to this runtime. Let's run another program, that is factorial, which is written recursively. So if I can go to this GKV file, yeah, as you can see it is written recursively. Now let's run this file. As you can see, we have given 3 as input and we got 6. So our program is strong enough to handle recursion. To mention about challenges, we had difficult times in developing the translator and runtime. You can find our entire project in GitHub. It has dedicated directories for grammar, compiler, runtime. Also, you can find some sample high-level programs and corresponding intermediate code there. Thank you all from Team 9. Hope you enjoyed it.